Hey, welcome back everybody. This video is going to be about dividing radicals, specifically square root, because that's really all we're going to need in our geometry module. And let's get right to it, because this might take a couple of minutes here. All right, so right away, if you're taking notes, this is 8.1.3. I'm calling it dividing radicals. And for you algebra people out there, yes, there's a lot more that can be said about this stuff than what I'm going to do, but it'll be sufficient to get us by. Okay, so here's the first property we have, and what we're saying here, this is a result of your rules of exponents, and since we are in sort of a time crunch, we don't really want to get into all of that. So the square root of a divided by b is equal to the square root of a divided by the square root of b. In other words, you could essentially sort of just take this thing apart and look at it in terms of its numerator and denominator independently. Now that also works in the other direction. If it's written this way, you can go back and write it as one big radical. And we'll see how it depends on your situation to which way you want to kind of look at it. Now the first example we've got here is the square root of 27 divided by 3. And I think I'm just going to work with the paintbrush here on this because it's just a little bit quicker. So let's write this. We got the square root of 27 divided by 3. Okay, so really all we can do here is simplify this numerator. First of all, 27 is not its simplest form. I mean, the square root of 27. That can be written as what's 9 times 3, right? So I'm going to say, well, hold on a second now. This is 9 times 3, all divided by 3. That's true. And the square root of 9 times the square root of 3, well, that can be a 3 root 3, because the square root of 9 is 3. And we're still divided by 3. And these two guys cancel to give me root 3. Pretty simple, right? Now I'm going to point something out here where a lot of people will make a mistake. Some people are going to try to divide that 3 into that 27. You cannot do that. This has to be a root to do that. You'll be applying your property incorrectly. For example, notice this has to be a square root to divide it in. Okay, so you can't take that 3 divided in, because if you did, look what you'd get. 27 over 3 is 9. Square root of 9 is 3. And we just found that it's not actually, it's the square root of 3. All right, so to simplify this thing, we found that this is actually equal to the square root of 3. Okay? All right, let's look at another example in this same video here. And I got something a little bit different here. Now, this time I'm asked to simplify, and really, if you had instructions on a paper or it's in Delta Math or an iExcel, more than likely they'll just say simplify, and they expect you to realize, hey, this is not its simplest form. And I'm going to go ahead and tell you right out of the gate, in the next video we'll see it. On our level, Math 1, 2, 3, advanced functions, whatever you got, probably pre-calc as well, they don't leave radicals in the denominator. And we'll see in a little while, they call that rationalizing the denominator. So anytime you see a radical down here, it's not in its simplest form for us, okay? So again, I'm going to go and take care of it right here. All right, so we had the square root of 10 divided by the square root of 2. And we need to simplify this. Now, I probably would say, well, you could rationalize this denominator, and you could. But I'm going to show you guys a trick here. The simplest way to see this is using the property in reverse. Since 10 is divisible by 2, this is your quickest way out. 10 divided by 2 is 5, so this is actually equal to the square root of 5. And we'll come back to this in another example in another video. But for now, this is what we need to know how to do. All right. Let's see. So that is actually equal to the square root of 5. And just remember that, and we'll come back to it. Okay, that's going to wrap this up. And we've got one more part of this division, and I wanted to do a whole new video on it because it might take 5 or 6 minutes. It's called rationalizing a denominator. And we'll probably come back and visit this one again too to show you could have done it that way. But this was by far the simplest way to have done it. All right, well, I hope this video is helpful for you, and stay safe and be healthy.